We are from ROI's Academy faculty team, and today we'll learn course CBSE Class 10, Subject, Mathematics, Chapter 2, Polynomials. Topic, Polynomials, Degree, Type, and Zeros. For obtaining similar video explainers, please connect Roy's Academy at 891-089-0311. Repeating the number again, 891-089-0311. Our another number is 891-0600-503. Repeating the number again, 891-0600-503. All right, hello everyone and welcome. Today we're going to dive into a super important topic for your Class 10 math journey, polynomials. We'll look at what makes them tick, how we can sort them into different groups, and then tackle this really cool idea called their zeros. So, you ready? Let's jump right in. So, let me ask you something right off the bat. Imagine you're looking at a polynomial. Maybe it looks kind of long and complicated. What if I told you there's one single number, just one, that basically tells you its whole life story? Any guesses? Well, it's the highest power you see on the variable. And that special number has a name. We call it the degree. And that brings us right to our first big idea. To really get polynomials, you've got to start by understanding the degree. It's the key to everything else. Okay, so here's the official rule, but don't worry, it's super simple. You've got your polynomial, right? Let's say it's p of x. All you have to do is look for the highest power of x. That's it. Whatever that highest number in the exponent is, that's the degree of the whole thing. Simple, but so important. All right, let's see this in action. Look at the first one, 4x plus 2. You might not see it, but that x has a little invisible 1 as its power. So the degree is 1. See? Easy. Okay, next one. 2y squared minus 3y plus 4. We've got a power of 2 and a power of 1. Which one's bigger? The 2, of course. So the degree is 2. It doesn't matter how many pieces there are, you're just hunting for the biggest exponent. Even with that monster at the bottom, don't get scared. Just scan for the highest power of u and boom, it's 6. So the degree is 6. That's all there is to it. Okay, this next part is like the #1 rule of the polynomial club. You want to join? Your exponents have to be whole numbers. We're talking 0, 1, 2, 3, and so on. No fractions, no negatives. So if you see a variable chilling in a denominator of a fraction like 1 over x, nope, that's a negative exponent in disguise. Or if it's trapped under a square root sign, also a no-go, that's a fractional exponent. Those guys are not polynomials. This is a super important rule to remember. It's the gatekeeper. So now that we're masters at finding the degree, let's see what we can do with it. We're going to use it to classify these expressions and give them some proper names. First up, we have polynomials with a degree of 1. We call these linear polynomials. And there's a good reason for that name. If you were to pop them on a graph, they'd make a perfectly straight line. Kind of cool, right? And just look at all these examples. The numbers in front of the variable, the coefficients, they can be anything. Fractions, weird square roots, whatever. It really doesn't matter. The only thing that makes them all part of the linear family is that the highest power on that variable is just 1. Okay, let's level up. What about degree 2? We call these quadratic polynomials. Fun fact for you, quad sounds like square, right? That's because the highest power is 2. The variable is squared. The standard way to write it is ax squared plus bx plus c. And here's a key detail. That a can't be 0. Think about it. If a was 0, the squared term would vanish, and it wouldn't be quadratic anymore, would it? And again, check these out. They can look a little different. Sometimes the x term is missing, or maybe the constant is gone. Sometimes the terms are all jumbled up. But don't let that trick you. Just do what we learned. Hunt for the highest exponent. For every single one of these, it's a 2. That's their family name, quadratic. I bet you know what's coming next. After square comes cubed. Yep. A polynomial with degree 3 is a cubic polynomial. Makes sense, right? The variable is cubed, raised to the power of 3. And just like with quadratics, that a in front of the x cubed term absolutely cannot be 0, or it's not a cubic. And here are some examples. A cubic can be super simple, like just x cubed, or it can be a big, long expression with all the terms. But what do they all have in common? You guessed it. The biggest, baddest exponent in the room is always a 3. Okay, great. So we know what they are. We know their family names. Now, what do we do with them? Well, we're going to start plugging in numbers. This is where we see how these expressions actually work. Finding the value of a polynomial is actually pretty simple. It's like following a recipe. So say you have p of x equals x squared minus 3x minus 4, and someone asks, hey, what's the value when x is 2? All you do is take out every x and pop in a 2. So it becomes 2 squared minus 3 times 2 minus 4. Let's do the math. That's 4 minus 6 minus 4, which gives us negative 6. So we write it like this. P of 2 equals negative 6. Done. So you can plug in any number and get a result. But every once in a while, you plug in a number and something magical happens. You get a very, very specific answer. And that leads us to this huge idea in the world of polynomials, the idea of zeros. Okay, let's stick with our friend. P of x equals x squared minus 3x minus 4. But this time, let's try a different number. I want you to find the value when x is negative 1. Go ahead, pause for a sec and try it yourself. What answer do you get? All right, did you do it? Let's check the work together. We're calculating p of negative 1. So we get negative 1 squared minus 3 times negative 1 minus 4. Careful with the signs here. Negative 1 squared is positive 1, and negative 3 times negative 1 is a positive 3. So we're left with 1 plus 3 minus 4, which is 0. Ding, ding, ding. That's it. That's the special number. This isn't just any old answer. Getting a 0 is a huge deal. So here's the official definition. A real number k is called a zero of a polynomial if, when you plug it in, you get 0 as the answer. So for our polynomial, we just proved that negative 1 is one of its zeros. And, just to let you in on a little secret, if you go and try plugging in the number 4, you'll find out it's a 0 too. Okay, now we're getting to the really cool part, the deep stuff. Is it just a coincidence that negative 1 and 4 are the zeros for that polynomial? Or is there some hidden connection between those zeros and the numbers that made the polynomial in the first place? The 1, the negative 3, and the negative 4. Think back to class 9. You've already seen this connection. For a simple linear polynomial, ax plus b, there was a formula to find the 0, remember? It was always negative b divided by a, you see? A direct link between the 0 and the coefficients. No guesswork needed. So here it is, the big question we're building up to. Does a connection like that exist for bigger polynomials too? For quadratics? For cubics? Could we look at the coefficients and predict something about their zeros? The answer is a huge yes. And figuring out that relationship is exactly what we're going to explore next on our polynomial adventure. This was an initiative from Roy's Academy faculty team, and today we've learned on course CBSE Class 10, Subject Mathematics, Chapter 2, Polynomials, Topic, Polynomials, Degree, Type, and Zeros. For obtaining similar video explainers, please connect Roy's Academy at 8910-890-311. Repeating the number again, 8910-890-311. Our another number is 8910-600-503. Repeating the number again, 8910-600-503.